All right, well, hello everybody. I know it's the Labor Day weekend, but during today's class, I felt like perhaps I was being a little long-winded and we're running behind. So what I wanted to do is kind of make it up to you all by putting together these videos that are instructional in nature. There's going to be several of them. This is the first about unit conversions. I'm going to show you the basics of unit conversions. If you're confused by this, please watch this video as many times as necessary to figure this out, because it's going to be all over the first exam and it's really, really important for you to do well in this class. The rest of the videos on unit conversions are going to be sample problems, of which I'll do several. After that, I'm going to talk about significant figures and their use in a subsequent video. So definitely check these out. So that you are ready to go when we come back after the holiday next week. You can also use these videos to help you study for the first exam, because again, this content is crucial. All right, so thanks, and here we go. Okay, well, let's just dive in, everybody. I'm going to show you all a foolproof way to do unit conversions. If you're not familiar with this already, this approach is not going to fail you. And I like to do this by asking students an easy question to begin with. What I'd like to do is, say we go to the grocery store, we buy 60 eggs, quantity 60, okay? How many dozen eggs is that? Now you might quickly say, oh, it's 5 dozen eggs. This problem is pretty easy because we're very, very familiar with this unit that we call dozen. We obviously recognize that 1 dozen is equal to 12 of something. In this case, it's 12 eggs. So we can quickly, in a division our head, figure out that 60 eggs is equivalent to 5 dozen. But what I want to key in on is the process that we mentally did to come to that result, because this process is what's important for unit conversions. What we did is we started with the quantity that we were given, which here is 60 eggs. We wrote the number and we wrote the unit of measure. We then took the quantity that we were given and we multiplied it by a number that's known as a conversion factor. That's shown here in green on this slide. Now the conversion factor is always a fraction. There's a number at the top that's called the numerator. The number on the bottom is called the denominator. Now the cool thing about the conversion factor is the number that's in the numerator and the denominator is always physically equivalent. It's physically equivalent. What I mean by that here is a dozen eggs is equal to 12 eggs. It's the same amount of eggs. It's physically equivalent. It's just different units of measure. So in the denominator, you see that we've got 12 eggs, whereas in the numerator, we've got 1 dozen. Now, how did I know what to put where? Well, there's a simple rule for this, okay? Look at the units you want to get rid of or convert away from. I call these the undesirable units. Now in this case, that's eggs. Eggs is the undesirable unit. You always put the undesired unit in the denominator or the bottom of the fraction. You put the desirable unit in the numerator or the top of the fraction. Here that's dozens of eggs, so that goes up top, okay? So desired unit up top, undesirable down at the bottom. The reason why this works is because the undesirable units will cancel out, be removed from the mathematics, and you'll propagate through the calculation only the desired units. Now here that's dozens of eggs, okay? Now when you're setting up a conversion factor, I always work to set up the units of measure first. I always put the undesirable at the bottom and the desirable on the top. The reason why I do that is it helps me keep track of the math, okay? Because after I write the units, I come in and I write these numbers. Here it's 1 and 12. And then it makes it easy to know whether I need to divide or multiply by these numbers to get my desired result. Now here it's really easy to see I just have to divide because we're very familiar with counting eggs and dozens of eggs. But in scientific circles, it may not be so obvious if you have to multiply or divide. But if you set up the conversion factor first to cancel the units, and then you plug in the numbers where they belong, it will work out in a foolproof manner, okay? So I highly encourage you to do this, okay? So this is basically our steps to success with these conversion factors. You start with the number that you're given, you write it down with the units of measure, you then write the fraction in a parentheses. This is going to be your conversion factor. You're going to multiply that conversion factor by the number you start with in step 1. In step 3, in the bottom of the fraction, you're going to write the undesirable units. Those are the ones that you want to get rid of. Then in the top of the fraction, or the numerator, you're going to write your desirable units. Now, after you do that, you fill in the numbers that are going to be attached to each unit, remembering that both the top and the bottom quantities must be physically equivalent. Now here again, a dozen eggs is 12 eggs. So again, they're physically equivalent, just different units of measure. Okay, that's got to be the truth or the case if this is going to work. And then last, you perform the calculation by multiplying or dividing whatever is necessary to get the correct answer. Okay, so this approach I highly encourage because it's pretty foolproof. If you struggle with this, review it over and over until you're understanding. So some conversion factors, like conversions between English and metric systems of measure, are not considered common knowledge, and these conversion factors will be given to you on exam. But remember, you must know your metric prefixes like milli, micro, nano. These are very important. You have to know the abbreviation, the letter, and also the power of 10 that they correspond to, and how to use these, how to convert between them. That's going to be very important for your scientific career. Another complication when it comes to unit conversions are units which are squared or perhaps cubed. Okay? Now, think about computing the area of a floor in a room. Let's say that you're in a room that's 5 feet by 5 feet, as shown in the picture here. This is not a terribly big room, but I think it's pretty easy to figure out that this room is 25 square feet, or just 5 times 5, 5 squared. It's 5 by 5, right? That's the surface area of the floor. Now, notice what I said, 25 square feet. What I want you to think about for a second is a square foot the same as a foot, or is it a different fundamental unit? I would argue it's a different fundamental unit. It's an area, not necessarily a length, okay? So in 1 square foot, would you then think that there are 12 square inches, since there's 12 inches in a foot? If you thought this, you'd be confused. There's actually 144 square inches in 1 square foot. What you missed was that you only considered one dimension, and you tried to apply a one-dimensional conversion to a two-dimensional area, and this is not correct. You have to remember to actually square the units as well, square the conversion. Sometimes this can get confusing, and I really like to draw it out when possible. Also remember, for three-dimensional objects or volumes like the cube that we considered in class, you have to consider all 3 dimensions when you're deriving a conversion factor for volumes. So for instance, if I had a block that was 10 centimeters by 10 centimeters by 10 centimeters, this would make a 1 liter volume, just like the foam block that we considered Friday in class, okay? Now, how many cubic centimeters is this? Well, it's 10 times 10 times 10, or 1,000 cubic centimeters, which of course is equivalent to 1 liter, okay? This is also 1 decimeter on edge. 10 centimeters is equivalent to 1 decimeter, so it's 1 decimeter on edge. And a cubic decimeter is also the same volume. It's also equal to a liter, okay? You just need to be careful not to think that because there are 100 centimeters in a meter, there must also be 100 cubic centimeters in a cubic meter. It doesn't work like that, because the units, once you start squaring them or cubing them, are not physically equivalent to the distance unit that you're trying to convert, okay? So whenever you're looking to generate your own conversion factor, which you might have to do for areas or volumes, draw yourself a little picture like these and think it out. I think that'll help you a lot. All right, so let's try a relatively simple sample problem. In this sample problem, we're going to consider the height of a waterfall called Angel Falls. I believe this is in Venezuela. The height of this waterfall is 3,212 feet. We're asked to express this quantity in miles if 1 mile is equal to 5,280 feet. That's by definition, okay? So we start with what we know. This is the 3212 feet as the height of this waterfall. We then decide that we're going to take that initial information and follow our protocol, which means multiplying by our conversion factor. The conversion factor, remember, is always a fraction. In the denominator of the fraction, or the bottom, we're going to put our undesirable units. Here that's feet, because we're converting away from feet into miles. So in the bottom of the fraction, we put 5,280 feet. In the numerator, or the top of the fraction, we put 1 mile. We know that 1 mile is physically equivalent to 5,280 feet. We were told that in the problem. These are exactly the same distance, just with different units. So again, our conversion factor is valid for converting into miles from feet. We complete this problem by performing the multiplication 1 divided by 5,280 multiplied times 3212. Or else you can think of that as just 3212 divided by 5280. This yields 0.6083 miles. So Angel Falls is 0.6083 miles high. You can see this is a relatively simple example, but it gives you the idea. The key to mastering conversion problems is practice.